credit for it.
It's true. It's a lot of hard work. We better get credit.
Okay, so number 1, what notation is used to denote the probability of an event occurring? And the answer was px. Is that what you guys got?
Yes.
Okay. So please state and describe the 3 rules of probability. Number 1, a probability is a number between 0 and 1. Number 2, if you list all the outcomes of a probability experiment, the probability that one of these outcomes will occur is 1. Number 3, the probability that an outcome will not occur is 1 minus the probability that it will occur. Number 3. I'm sorry?
Oh, I was just saying that is pretty basic.
Yeah. Yeah, these are like just definitions, so. Okay, so what does it mean to be random? When something is random, it follows a long-term pattern, but we usually do not know the outcome of the next experiment. What does the phrase discrete random variable mean? So a discrete random variable is something that varies following a specific pattern or distribution over the long run. And it can be discrete and listed in a list.
Okay.
Okay. So for part 2, a 4-sided die has 4 possible outcomes for each roll. Calculate the mean of this discrete random variable. So I wrote them out, and it looks like that. It's really, it's just it's just the same thing as a graph, but it's I just wrote it out instead of putting in the lines.
Were we supposed to make a graph?
You didn't have to.
It doesn't say make a graph, so I'm guessing no.
No, you can do the problem without making a graph. You just organize it that way.
Okay, go see grandma.
The answer was 2.5.
Go tell grandma. Yes, I got the same.
Okay. Does anyone have any questions about how to do that one?
See, I thought this first lesson was pretty easy.
Yeah, I thought so too. And the second question was similar, but it just had a few more steps, right?
Mm-hmm.
You add them up, square root.
Right. And you kind of just follow the equation. And I got, well, for the variance I got 1.25, and then for the standard deviation I got 1.118.
Ooh, I got 1. Oh yeah, that's right. But then you rounded it's 1.12.
Yeah. I can't tell if we're supposed to round or not, because sometimes I think they round, and then other times they don't round. And my husband told me that in statistics, people usually go out to the 4th decimal.
Okay.
The 4th number. So I've just been using 4 numbers, and I don't know if that's right. Anyway.
I think I got the 1.12 from the answer key, though, because that's what I did. I wrote the whole number out all the way. I wrote out 10 decimal places because I wanted to make sure I was right.
Mm-hmm.
Okay.
Okay. Well, we got that one right for sure. Okay. Now we can move on to the next lesson.
Do we want to do the homework?
Wait, yeah, we're supposed to do the quiz.
Oh, the quiz.
The group.
Oh, yeah, let's do the quiz first while this is fresh.
Go upstairs and go see grandma. Yeah, go tell her. Papa. Later. Yes, Emma, yes.
Okay.
Emma, I'm trying to do a quiz. No. Yes, your hand is open.
Oh.
You guys are all in California, right?
Yeah.
It's raining here.
It's raining here too. Not
It's
hard, but yeah.
Not raining here, see? That's because I live in Southern California. Okay. So I did this.
Okay. You guys ready?
Yes.
Yeah.
Okay, me too. Okay, I'm starting now. Alright. The first two are easy. And then number 3. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States which eat with each of these blood types is summarized in the following table. The blood types and the proportions given in the table define a probability distribution.
Where's my paper? Okay. So, yeah. I would say true, right?
I'm not sure I know how to figure this out. Just let me look really quick.
Because wouldn't it be like the table in our homework with all the shapes and the numbers for the states?
Well, we can look at the 3 rules of probability, and the first one says that an event X is a number between 0 and 1. And those.
Yeah, it fits that rule.
But it doesn't fit all of them.
Define a probability distribution. So wouldn't it, the probability distribution be the little bell-shaped curve thing? And it would make a bell-shaped curve. Maybe not. Depending on what order you put it in, it would have a skewed right curve. But that's a probability distribution, right?
Yeah.
What is the probability?
Okay. I'm gonna add them up and see if I get 1.
I say no. Wait, 8, 9, yeah. Should get 1.
Yeah, you get 1. So I would say that's true.
Okay.
So does it have to fit the 3 rules or just at least 2?
Well, if it equals 1, where's the rule? The sum of all possible outcomes equals 1. The probability that the event will occur is 1 minus. Yeah, I don't see that it doesn't. They're asking for a proportion here, though, but not a probability. You know what I mean? Okay. Number 2. What is the probability that a randomly selected person Okay,
You
so
can,
go ahead.
are we allowed to retake this one, or is just the homework that you can retake? Because I remember you can retake one of the quizzes.
I don't think you can retake this one.
So it's the homework that you can retake?
Yeah.
Okay.
Okay, so did we decide on number 3?
I just put true.
Yeah, because it fixes what we were trying to figure out.
Okay, so what is the probability that a randomly selected person in the United States has a type O blood round to 2 decimal places? So then do we have to isn't it just 0.45? Like, isn't there no figuring involved in that one?
Are we supposed to be using the information from the question number 3?
Yeah, I think so, since it's talking about type O blood.
Yeah, the probabilities are right there.
Isn't it minus 0?
So it's 45.45. It's giving you the answer. But that's the proportion.
Yeah, don't you do probability in percentages?
Yeah.
So do we? Well, there's no rounding then. It's just 45%.
But it says round to 2 decimal places.
Right. But it's asking for the probability, which usually isn't put in decimal form. So should we just leave it in decimal form? But I think you're right. I don't think we have to do anything. I think the answer is right there.
It matches with the homework questions in the homework assignment that say, randomly select a student in the class. According to the table, what's the probability of selecting a student not from Utah or California? And then you have to add up the 2 to determine it. So the probability is, oh, except for I subtracted from 100. So if there's 100, so if you're going to, oh no, it's not from, okay, so yes, I think you're right. I think it's either 45% or 0.45. And then if we do the one that it's not, number 5 is not, then we subtract 45 from 100 and get 0.55, and that's the answer to that one.
Okay, so should we just put it in decimals?
I am, because it says round to decimals.
Yeah.
Same with question 5 is wants us to round it out to 2 decimal places.
Yeah.
Yeah. Okay, so 4, like you said, Carrie, is 0.45, and then 5 is 0.55 because you just subtract.
From 100.
Yeah.
Are you talking about number 5?
Yeah.
Mm-hmm.
So 100 minus 45?
Yeah. Okay, number 6. Caroline Williams and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Okay, so there's 7 bowls.
should just be 1 out of 7, right?
Right.
Yeah.
So.
So it's just like 1/7?
No, you have to
It's
do the
decimal. 3 decimal places, so
So
1 out of 7, or whatever that is.
You divide 7 into 1, and it's 0.1428.
Well, yeah, I
So-
got that. I just meant, like, that's it. That's all we have to do for this one?
But are we running the last third
Yes.
decimal? Like 0.143.
Yeah. I think so. Okay, in a combined. Shall I read?
Sure.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer. I say the first one, strong evidence.
Yeah, if there are 7 bowls each time, I think that's pretty good.
Yeah.
Okay.
Don't touch computer.
So okay, never mind. Moving on. We got that one.
We hope.
Emma.
Yeah, hopefully. Sometimes it's questionable whether or not I have something. Okay, sorry.
It's okay. I did mine a couple of days ago, so I'm like, okay, let's remember what I learned.
Yeah, me too.
M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of M&Ms was given the following table. We don't have green. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Okay, so first we have to figure out what green is.
Okay.
So 0.13, 4, 2, okay, it's 0.16. Do we have to? What does the preliminary say? Okay, so I think that's actually the answer to number 9 is 0.16. So then we can.
Oh yeah, that's right.
What is the
Okay,
probability?
and then 10 is just the opposite. That one's 0.84, right?
Yes.
Because if you add them all up, I got 0.84.
And the probability of drawing red is just 0.13, right?
Yeah. It's right there. It said something.
Do we have
Yeah.
to put zeros? What do you think? Do we have to put zeros in front of these numbers?
I haven't been.
Okay, fine. Okay. All right.
I guess if we get them all wrong, we'll know what we did.
That will be very sad, and I will.
Yeah, I will complain to Brother Bald. What did I do?
Okay, the ACT scores of students admitted to a medium-sized public university in the Western United States were taken from CAPEX.com. The following summary statistics were calculated. Use the information from the public university to answer the following question. Half of the observations are less than or equal to what number? Description.
Would it be the mean? Oh, wait, no.
Emma.
No, that's what I'm thinking. It's the mean. They're less than or half. It's the middle. It's the half.
Yeah. Oh, yeah, half. Okay. Yeah, I think you're right.
So do we just write the number or we just type the mean?
To what?
What number? So 24.3.
So do we write just the number 24.3 or write with the word, the mean?
I
I
think
wrote
the number. Because it says what number.
Okay.
The top 25% of students scored in what number?
Would that be 27? The Q3?
The top 25% would be the first percentile, right?
Yeah.
So that is the maximum number, so it's 35.
Okay.
But wait. But I thought that it's like 25 percentile and then the second is the mean and then the last one.
I'm sorry, what?
On the top, never mind. Yeah.
Okay. And which of the following statements is not one of the three rules of probability? Not a criticism of probability. Okay,
I got D. Is that what you got? D?
Well, I don't know if they're scrambled this time, but it's the one that says if the probability is high, then the probability is positive. If the probability is low, then the probability is negative.
Yeah.
Okay.
Yeah, because the other ones sound they're right.
They're right, yeah.
Probabilities. Use your fingers, Emma.
Submit and see how we did.
Are you afraid of so many next?
Yeah.
I'm afraid that I didn't enter my numbers correctly and they need zeros or something. Okay, here I go.
Emma.
I got a B.
A B?
Me too.
11 and 12 are wrong.
I can see Emma. Move your fingers.
Uh-oh.
12? I got that 12 right.
Not according. You got 12 right? What did you put?
27. Because that's it. The Q3, the third percentile. That it says 27 right there. Because it's like 25 is the first percentile. That's the lowest score. I'm trying to do quizzes. And then the second one is the mean. And then the last one is the third percentile, which is the top 25% of all the scores. The maximum is still like, you can still have, you know how you can have it skewed to the right or to the left?
Yeah.
The
Yeah.
maximum is still not part of the...
It would be the end number.
Yes. Emma, shh! Go see your grandma. You're not letting me do homework. Come on. Go see your grandma.
All right, well.
Go see grandma.
We're going to go over the homework now. How did you do, Emily? Did you get a B? 86?
Yeah, I got an 86.
For
Jennifer,
what?
yell at us next time.
the homework assignment are you talking about, or just a quiz?
No, I was looking at the quiz.
Oh, the quiz, let me see.
But now we can move on to the homework if you want.
Yeah.
Are we supposed to work on the homework for the lesson 4 too, or just the quizzes, the group, meaning part of it?
I thought we were just supposed to go over it.
For the
Yeah,
homework?
What? No, we go over the individual prep and then we do the quiz, and now we're moving on to lesson 5. Is that what you're asking?
Yeah. I got 93 for the quiz that we just took.
Great.
Next time, yell at us because we got one wrong.
Okay, for lesson 5, are you guys ready?
Yes.
Okay, so number 1, part 1, we were just supposed to classify them as unusual or usual. And for A, I got unusual. B, I got not unusual. C, I got not unusual. And D, I got usual.
Yep.
Okay. Does anyone have any questions how to do that? Okay. Okay, number 2. Find the probability that a randomly selected professional baseball player will have a batting average that is greater than .335. Use the z-score and the normal probability applet to find the probability. So, I got 1.48% will have a batting average of 335.
That's what I got.
Mm-hmm.
Okay. Okay, just let us know if anyone has questions or how to do something. So number 3, provide a brief description of the normal density curve. Describe the shape and properties. The normal density curve is symmetric and has a bell shape. It is determined by its mean and standard deviation. Okay, for number 4, in the following z-score formula, please state what each symbol stands for. So the z is a z-score, and it tells how many standard deviations away from the mean a certain observation lies. X is the data point. I think it's pronounced mu. The U thing is the mean of the population, and I don't know what the other one is. It's a standard deviation, but I don't know how to pronounce the symbol.
It's a curly O.
The curly O, okay. Kind of like, yeah, okay, makes sense. Standard deviation for the curly O. Number 5, in no less than 3 sentences, please define and describe the 68, 95, 99.7% rule. Okay, for any bell-shaped distribution, 68% of the data will lie within 1 standard deviation of the mean. This is what the answer key says, but I just copied and pasted from the
Emma, take it to grandma, please.
textbook in mine, and it just says 68% of the data will lie within 1 standard deviation of the mean. 95% of the data will lie within 2 standard deviations of the mean, and 99.7% of the data will lie within 3 standard deviations of the mean.
That's what I got.
Okay, so part 2. So did anyone, did you guys notice that they on the homework, on the individual prep, what was supposed to be A is actually just like the 6 is just the introduction to the problem.
Well, I thought this whole thing was a little bit messed up. Like it was off.
Really?
Is this the assignment, maybe, or was it the homework that the numbers didn't even match what was going on? There was like extra questions in there. Maybe it's the homework.
Yeah, there was an extra question, but
Okay.
I think I got the same things as the answer key.
Maybe it was the other one. Anyway, it was one of them was really off, and it wasn't making sense. Oh, it might have been the lesson 4. Never mind.
Okay. So for number 6, A says what proportion of the people who take the quantitative portion of the GRE will score above 165, which is actually B on not the answer key on the normal individual prep. Does that make sense?
Well, I'm assuming we're all looking at the same individual prep, so that even though it was just 150 for the mean and 8.8.
Yeah, and 8.8 for the standard deviation.
Okay.
Yeah.
Yeah.
So then the next one down.
It just told you that.
Right.
Okay, so B, what proportion of the people who take the quantitative portion of the GRE will score above 165? And I got 5.325%. Oh, that's slightly off. But it's basically.
We're still on number 6?
Yeah.
I got 5.33, but I don't know what the other decimal place was to round it.
Okay.
What was the answer key?
It says 0.0533. So yeah, you got it. I just am like 1 decimal point off.
Possibly just rounding, isn't it?
Yeah, I may have rounded at some point. Okay, and then for C, hold on. C was, if a student's score is the 10th percentile, what would their corresponding z-score be? And I got 1.282.
For
I'm not looking at the right thing.
the 10 percentile is just like to the left, so it's -0.1, -1.2816.
That's what I got. Because the 10th percentile is at the other end of the bell curve.
Oh, so it's negative.
Right.
Okay. I just didn't catch that. Okay, for D, what is the quantitative GRE score for a student who scores in the 10th percentile? And what did you guys get?
139.5. But you have to rearrange the equation so that you're solving for x.
Uh-huh.
And then you have to enter it in your calculator right, because that's what I did about 6 times. I couldn't figure out why I didn't get the right answer. But if you put it in the calculator right, it comes out 139.5.
Okay.
Is that what you got?
Yeah. Okay, so number 7. The mean speed of hydrogen at room temperature is 1,800 meters. Is it meters?
Per second? I don't know.
Yeah. With a standard deviation of 600 meters per second.
And then it
At
did
room.
again.
Oh yeah, it did the same thing again. They answered right there. 1,800 and then 600.
Yeah.
Okay, so what probability that a randomly selected particle has a speed over 2,500 meters per second? And I got, let me see, 0.1217.
Right.
Okay. Sorry, my work is like crazy, and I like lost where I put the answer. Okay, we got that.
Emma, get away from the TV. Thank you.
Okay, so what is the probability that a randomly selected particle has a speed that is less than 2,500 meters per second? And I got 98783.
I got 8784, but I think I rounded.
Okay. Same thing. Okay, next question. What is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? And the answer is, hold on. .3085.
That's what I got.
Yeah.
That's
yeah,
right.
that's what I got too. Okay, and then
Emma.
what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? And the answer is 0.5698.
What letter are we on?
17.
Yeah.
Okay.
Yeah, that's what I got.
And I did 5.5699. So close.
Yeah, you probably just rounded. That's fine. Okay, so for F, what is the third quartile of the speeds of hydrogen at room temperature? And I got it.
That's 75.
20. I'm sorry?
75. For the letter F, what is the third quartile of the speeds of hydrogen at room temperature?
What did you get as the answer?
75.
I got.
No, see, I got 24.694, and I wrote down here that I was close, but I wasn't right. I have to look and see what the answer
It's
was.
the same where you're solving for X. And you just have to.
I didn't get it. I didn't get it right, or whatever it was. Number F.
Okay, do you want to go over that? Or should we keep going?
We're almost, like, we should be almost done with, we just have one more question.
Okay, so the answer from the answer key is 2204.4 per second.
Yeah.
Oh.
And I did it the way they said to do it, but I didn't get that on my calculator, so I'm not sure that it matters.
Well, you're like 1 decimal point off. Like, you got the.
After my decimal, I'm 694, though. That's not 0.4. I don't know. It's still. I don't know. I guess yeah, I'm afraid it'll still get me wrong on the test.
You can get very close. Yeah, I don't know what to tell you.
Yeah, that might just be my calculator. So.
Okay. Okay, number 8. Determine whether the data represented in these Q plots are normally distributed or not. Record your answer for each graph. So for A, I actually find this kind of like difficult. The ones that were normal or not normal were like some of them were obvious and some of them were not obvious. So for A, I got not normal. And for B, I got not normal. C was normal. D was normal. E was not normal. And F was normal.
What I got?
Yeah.
Okay. Great. So, should we start the quiz?
Yeah. Hopefully we do good on it.
Yeah, so I think we have to have the normal probability applet up for this quiz.
What are you doing?
Okay, are you guys ready?
Yes.
Hold on, I gotta find that. Oh, here it is.
What do you want to do? Always doing a quiz. Careful.
Okay. I'm ready.
Okay, so number 3, the total area under a density curve must equal, is it 100% or 100 or 1?
1.
Okay. Okay. Is everyone okay with that?
Yes.
Okay, so number 4, under certain circumstances, a density curve can drop below the x-axis.
That is false.
Yes, I agree with you.
One of the reasons is because, I don't know all the reasons, but from the last lesson, by definition of now I can't find it. Anyway, it says it doesn't ever pass the access. No, I don't know where it is. But I read it.
Okay, I trust you.
That's good, because I got the last one I was sure on wrong, right? Normal density curve is symmetric.
I put true. Yeah. Okay. Which of the following elements of the figure represents the z-score in this image?
C. Right?
Yeah. Yeah, that's right. Okay, 7. Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
B.
Yeah. Mm-hmm.
Okay. 8. According to the 68, 95, 99.7% rule, what proportion of the data from the bell-shaped distribution will be within one standard deviation of the mean?
Okay, I would love to know the answer to this question because I could not do one of the homework questions that sounds just like that. What?
Was it just 68?
Will be within one time.
It says 68% of the data will lie within one standard deviation of the mean.
So
That's what the textbook says.
It's what's between the red lines, right? But
Yeah.
the question is what's the proportion? So what is the proportion?
Oh, what's the proportion?
How much of it? 68%.
Emma, I'm trying.
It does say what percent. Then maybe it is 68%.
I think that's right, but I don't really trust myself that much.
All right, what do you say, Jennifer? You were right last time when we were wrong.
Well, I'm thinking. Yes. So the first line is for what it says letter H, where the 68% is right.
Mm-hmm.
I think that's the first standard deviation. So yeah,
68%.
I agree.
Okay.
Okay, number 9. Suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places. Okay, so I think we put the z-score in the normal applet.
So one.
Emma.
Okay, so if you do that, then the area comes at 0.3173. Because the z-score is 1, right?
Yeah.
What is it? What is it? 317. So it's 317.
Yeah.
Did you put it in the?
Applet?
Yeah. Like, how did you get that number?
I just put 1 in the z-score section, and then the area at the top comes up 0.3173.
Because mine says 0.6827. Is the only the middle section highlighted blue?
Oh, no.
Because I think that's what we want.
Not the sides? Okay, wait, let's read the question again.
Well, what proportion of the values from this random variable will be between -1 and 1?
Oh, you're right. Good catch. So 0.683 is the answer then if we round, right?
Yes. Okay, is everyone good with that answer?
Yes.
Yes.
Okay, so number 10, suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2?
0.955. Right?
Yeah, I think you're right.
Shocking. They match up with that whole 68, 95, 99 points. Okay, and 11 is the same, only you make it 3, right? Between.
Yeah, 11 is like the same.
Oh, look carefully at your answers to the last 3 questions. What do you observe? The values match the 98, the 68, 95.
Also shocking.
So for 11, you did get 0.002, right? Wait, no. 0.003.
No, for 11, make sure your blue section is in the middle.
Wait.
Wait, what did you get, Carrie?
0.997. Well,
Yeah, that's what I put too.
Mine says 1, the area. And I put -3. And the other one just 3. I see 1.
it says 1.
For mine,
It says 0.9. Is it rounding something?
I don't know. My computer might be rounding it up.
I've got 0.997, which matches the whole. It will. The whole 68, 95, 99.7 rule.
True.
That's what I have too.
All right, should we go on to the next one? Did you get it, Jennifer?
I got it.
Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.66 grams p times kilograms to the negative 1th power times d to the negative 1th power, and the population standard deviation is 0.07 grams. Yeah, you can read that. Use the information to answer questions 14.7.
14
14
to 17.
through 17.
So
Yeah.
then, shouldn't it be 13 then? It's part of it.
Less than 0.60 is. All right. This is one of the ones I was having trouble with. How do we solve this problem? Like, what is there an equation that goes with this? Maybe I didn't have problems with it. So we'll see.
Okay.
So we have to figure out a z-score for this one and then put it in the applet.
I think you're right. Sorry, it just takes me a long time to like put it together with what we're doing. Like word problems always throw me off.
Okay, so.
Okay, so the mean is.
Well, the formula is x mean divided by x minus the mean divided by the standard deviation, right?
Mm.
So
Yes.
X
Yeah, that's right.
Minus 66 divided by 0.07.
So do we wait? What's the data point?
It's the point given in the problem, 0.60 grams.
Okay. Oh yeah, you're right.
Sit down.
Okay. I don't know if I got that right. Hold on.
Did you get a negative number?
I got a negative number, but it's big. Let me try again. It has to be. A negative 0.8571.
That's what I got too.
Okay, so the z-score is negative 857. Okay, so now I think we put that number into the applet. 851. And the probability is 0.6086. Wait, hold on. That's not true.
No, I got 0.391 if you run that out to 3 decimal places.
The portion of the population having a protein requirement that is less than 0.60, give your answer as a decimal. So we have to light up both sides, right? So the blue should be on the left and in the middle. That's not right.
Shouldn't it be on the sides?
Well, it has to be the left then. I mean, it has to be less than. So shouldn't it only just do the left, to the left of the negative bar? To the left of the left-hand red bar. Is that correct?
Yeah.
Did you get 0.1957?
Yes, if that's the correct way to do it.
Okay.
But then you have to round it up to 3 decimal places, so it'll be 0.196.
Right. But is that the correct way to do the problem, is the question.
I don't know. It seems right, but, like, I've done that before where I do the problem and then I was supposed to do it, like, a different way.
Let's see if we can find one that matches this. Okay, so here's one in the prep. What proportion of the people who take the quantitative portion of the GRE will score above 165? Figure out the Z-score. Use the app. Let's see if I can do this. Just a second. I'm going to do this other problem to see if we did this problem right. Let's make sure I did this problem right. Yes, I think we did it right. Based on the other problem.
Yeah.
If you're gonna draw, you have to draw.
Yeah, that's right.
Draw a Pokemon.
So the answer is 0.196.
Yes, I got the same.
Okay. All right, next question.
So more than...
What proportion of the population have protein requirement that is greater than? So that we
Do
should
we just
be able to move
look
it
at the applet?
Yeah.
Yeah.
It's the same answer then,
Yeah, I
right?
got the same
So
one.
move it to the other side because now it's more than instead of less than.
Yes,
Yeah.
but still the same answer. At least that's what I got.
I got 0.8043. Because you have to fill in the center and the right.
But then that will be less. But that will be onto the negative side too, negative 0 point something, and it just says more than 0.60.
Right, but okay, so for the problem above, when you look at the bell curve, hold on, maybe I can do the screen share thing to explain what I'm doing. Emily, how do I do the screen share?
You just scroll over to the left side of your Google thing, and you go to the wrench with the camera. Oh wait, no.
No,
No,
it's like
the
this.
green
square.
arrow. It's a white arrow with a green box underneath it.
Okay. Okay, can you see it now?
Uh-huh.
Okay, so for the number 13, we should have it lighted like this because it's less than this line right here. For number 14, we have to have it like this because it's more than this line. Because this is the 60.60, whatever it was, 0.60. What's the question?
But it seems like 0.60 would be over there by
the right side.
Well, then this problem is wrong. We should the 13 is wrong. 13 should look like that then. Because the Z-score was the
Yes,
negative.
I agree.
Okay, so what are we agreeing to? This is
0.804.
0.804 for number 13, and then 0.196 for number 14.
Okay, so we're switching them.
Wait, what? We're switching them?
Hold on. Okay, so Jennifer is saying that 13 should look like this. So this is the answer to 13. And then this is the answer to 14.
Okay.
But here's my question, Jennifer. When we
Okay, go ahead.
when we do the z-score for 0.60, what's the answer to the question? 0.60 grams or whatever it is. When we do that z-score, it comes up a negative number. So here's the negative number.
Uh-huh.
So that's why I based it off of this line, this red line. It's not a positive number, which is on this side. That's why I'm questioning.
For number 13 or 14?
13. Or does it matter?
Well, it says less than 0.60, so it's where the last.
This is 0.60 right here.
I know, but you have to click on the left side of that line, both sides. That
So
one and that one, and remove the right side.
This is the answer to 13, and this is the answer to
14. Uh-huh.
Okay, can I put it down now?
Yeah.
Okay, so 196. All right, got it. I hope that's right.
So, should we move to 15?
Yeah.
Uh-huh.
Okay, so what proportion of the population have a protein requirement that is less than 0.70 grams? Give your decimal, give your answer as a decimal to 3 places.
So it's the same thing with 0.70.
Can we do that with the applet?
Well, first you have to figure out the z-score.
Oh, that's right.
Oh, because it's different. It's not 0.60, it's 0.70 now.
Right.
I see.
Okay.
Did you guys get 0.573 or 0.571?
0.5714 is what I got.
Yeah, that's what I got too. Sorry.
But we
For
still
the
only
z-score.
we only use 3 decimal places, though, right?
Right. I just put the fourth one in there so that I remember to round it. So I remember which way to round it.
Okay.
Okay, so what is the question? What proportion of the population have protein requirement that is less than 7? So based on the last question, we're saying that the right-hand red line is the 70. So then that makes it 0.7160.
0.71 what?
0.716 with a 0.
If we're filling in the middle and the top.
The middle and the left.
Yeah.
Yeah.
I got 0.716 if you round it up. Because it's 0.7157, so I'll round it up to 0.716.
Right. Okay, here is a question. 0.716. Okay, I'm going back to 13 and 14 again. Here's the thing. I know we rearranged it so that we said 0.60. The mean is 0.660. So if we're looking at that bell-shaped curve, the mean is in the middle, right? It would be the highest point.
Mm-hmm.
So if we go back to, oh, I'm on the wrong screen. Hold on. We go back to 13 and 14. So if we're doing 0.70, then the red line is the 0.70. If we go back to 0.60, the red line should be on the left. I'm not sure 13 and 14 are right, because the mean is 0.66.
So you want to switch it back?
Well, I'm just trying to make sense of it. I'm okay either way, but I'm trying to make sense of it. If the mean, the high point of the bell-shaped curve is 0.66, then it seems like and they're asking how much is less than 0.60. That number is smaller, and it should be on to the left of the mean. Am I correct? Am I even making sense?
Are you asking me or are you asking Jennifer?
I'm asking whoever thinks they have an answer.
I thought the first way that we did it right was right.
But then we switched it.
Yeah, and I mean, I trust you guys. I really am not good at math, and so like, I'm trying. I don't know.
Jennifer, what do you say? You see what I'm saying about the mean being the middle and that 0.60 being to the left side, not to the right side? Because we're highlighting that middle section, and I'm not sure that middle section should be highlighted for what is less than 0.60.
So you just highlight the positive, not the negative? Is that what you're saying?
Here, hold on. Let me share my screen again so that I can. Okay. Well, now I have to get the problem back up here. The portion of the assignment is 0.60. Except that these rows. So as we said, the z-score for, this is 13 and 14 I'm doing, was 0.85. 571. Okay. So in the problem it says that the mean is 0.660. So let's say the mean is here, right?
Mm-hmm.
And then the question asks, what proportion of the population have a protein requirement that is less than 0.60? So 0.60 should be left of the mean. It should be here. So I don't think this part should be highlighted. I think this part should be highlighted for number 13. And then when it says how much is more, then this should be 14. I think we have them backwards. That's just my thought. Because then when we get to the next problem and it says when it is asking us for 0.70 and we're saying 0.70 is this line, that's more than the mean. That makes sense to me. But 0.60 is less than the mean, and it's over. Seems like it should be over here.
But that's negative. If you're looking at where the 0 is, it's negative.
But the score from 0.60 was a negative number, and it is less than. You know what I mean? I think I'm willing to try it. If you guys want to keep it, I think I'm willing to take my answer.
What do you think, Emily?
Well, I thought we had it right the first time. That made sense to me, but now since we've explained it like 50 times, I'm a little confused and I don't really remember what we were doing when we did it the first time. So I think the first way is right because that's what I thought before, but I'm just like I haven't done math in so long and I'm really, really bad at this. So
well, we don't all have to do the same thing. I think I'm going to change mine, and if you don't want to change yours, I understand, and we'll see who got it right, and then we'll know.
So you're saying one of us will submit it first to see which one's right?
Well, I don't know about that. However you want to do it, that's fine.
Okay, I want to leave it the way it is right now.
Okay, I'm going to switch mine. Okay,
okay, so 13, I put 0.196, and then 14 was 0.804. If we switch it back?
Yes, that's what she's saying. It's backwards.
Okay. Yeah, I switched mine back, and we'll see.
And if it would be the one with the A, and we'll get the B's again. Okay. All right, I'm done with that problem. We can go on to 16. Sorry.
Okay. No, it's good that we talk about it because that's how we figure it out. Okay, so find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70 grams. Hint, remember that to find the area between two values, shade to the left of each z-score. You calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values.
Okay.
Give your answer as a decimal. Okay.
So this one is just like number 7E on our homework, so we just subtract the two probabilities. So our probabilities were, did I write them down? Between 6. So greater than 6.0, right? 8.1.
I think this problem I struggled with.
Okay, so if it goes back to like the one in our preparation of 7E, then you take the probability, or the probability from what's greater than 0.60, and the probability from 0.70, what portion?
I got the right answer when I did it, but I think I did it a different way.
What is the precision? Okay. I got .088. But Jennifer's will be different because she wanted to keep the problem the same instead of switch those numbers back from 13 and 14.
Will you show me, or like tell me what you did
Yes.
for that one?
Okay, so what I did was I took the probability from 0.60, which we got is 0.804, 0.8043 if you want to be 40 out.
Oh, okay.
And
One
then
second. Somebody's at the door. I don't know who that is. I'm gonna just check.
Hi. I have a register for you. You got to sign for. Okay, you just got to sign right up on it.
then take the Shall I keep talking, or did she leave?
Yeah.
Grab the nail.
Okay.
No.
And then take the probability from 15, which is we got .7163. If you want to go out again, go out in a third decimal, fourth decimal place. Subtract the two of them, and I got .088.
Emma, go give it to Grandma.
So just subtract, basically.
Make sure your answer is positive. It's positive.
Give it to Grandma.
That means that should be the probability between
Go give it to your grandma.
0 and .70.
Emma, give it to grandma.
Actually, what?
If you're not giving it to your grandma, you're gonna get in trouble.
Okay, that's what I got. What do you think?
It seems right to me.
Yes, your grandma. Go see grandma if you want.
Your answer is accurate.
I think 17 and 18.
You think what?
I think 17 and 18 are like F from the homework.
35th percentile for the protein requirement for adults.
So 17 and 18 depends on number 16 for the answer.
Oh, I don't actually know. I'm not sure I understand the percentile thing.
Emma. But are we using those the information for the last question, 16?
I don't know. How do we find a percentile? Find the percentile for the protein requirement for the adults.
Emma, I'm almost done, okay? Wait for mommy and then we can play after.
Oh, don't we just have to
Did we just solve for X for this one?
I'm not sure I got this right, but don't we just have to put it in this applet? 0.35. I don't know what the percentile is. 35th percentile. And then, maybe it's coming to me. No, it's not. Let me see if I can look in the book.
Emma, this is mommy's homework. You can't touch computer. No touching.
Calculating percentiles.
No touching computer.
Okay, so I see it. It's in the book. It's just below the example of the applet. So you put the 35th percentile into the applet. It spits out a z-score. Use the z-score into that equation that you have to, but you have to turn the equation around. So you're solving for x in the equation that does the z-score. Did that make sense?
Yeah. But wait, do we know the z-score?
Put 30.35 into the applet.
Where the area is?
Yes.
Oh, yes, you're right. I did this yesterday. And then it gives you the z-score, right?
0.935.
So if I put in 0.3, okay, so here's the question. What do I highlight?
Go tell your grandma. She can help you. I'll be back, Emma. I can help you later. No biting blankets. Go upstairs with grandma.
Okay, when I put it in the applet, it like breaks out and turns back into one and doesn't do anything.
But I was supposed to be like playing around with the blue sections and stuff.
Yeah, okay, so the percentile is the number, for example, the 25th percentile is the number. Click on the areas under the curve only and to the left of the pole. Okay, so it's supposed to be the numbers to the left of the positive z-score are highlighted. Okay,
So the middle section.
The middle section and the left section. So if we put in 0.35, it won't light up the middle for me.
It's just the last section where the negative numbers are. So it says 0.385.
Is the z-score, right?
Yes.
Oh, yeah, that's what mine says too. Finally, you have to put 0 point and then the number.
Okay, and then minus the mean divided by the deviation, which is 0.7. What is that? I thought I wrote that down. What is the is the equation the one that goes x plus mean, x equals mean plus z times the standard deviation? Is that what it is when we turn it around because we're solving for x?
I was doing the x minus the mean over the standard deviation.
Yeah, but we're solving for x.
Right. So you put the z-score equals 385, and then you go backwards. Am I doing this right?
I don't know. Hold on.
I got 0.68695.
Sit down, you're gonna fall. Emma, sitting. Sitting. Hey. Sit down. Go upstairs. Come on. If you don't listen, your blanket will go away for the rest of the day. Go on the floor. Don't sit on the chair. Down. Down all the way. All the way. All the way. Keep
Emily,
going.
what did you get?
Down.
I got 0.68695.
Okay, so did I, but I did it the way I said, by flipping the equation around. So we both got the same answer, however we did it.
Yeah, well, I just did the same equation, then I worked backwards, like algebra style.
Good job.
So you got
algebra.
so you got the same answer, both of you.
Yeah. So is it 68?
Uh,
0.670? It doesn't say what we should
Sit
put
down.
for
Right here.
decimals and stuff.
let me see if that's going to be the answer.
Quiet down. You got algebra. You hit your head by yourself. Now stay sitting.
It looks like it's supposed to be answered in a percent.
Quiet down.
Calculate in a percentile. The answer
So
comes.
it's supposed to be
Oh,
by
no.
percent, like percentage wise.
The 95th percentile of the barrier. Okay, so that means 9% players. It looks like it can be a decimal.
Are we still on number 17 or are we doing something else?
Okay, the
Yeah,
question
we're
is
still-
how to enter the answer. Is it 68% or is it 0.68? Actually, it would be 7 if you rounded it. 687. I vote for 0.687.
Okay, in the prep assignment, it says the z-score of the 75th percentile is, and then it was a decimal. But then when you solve for x, the answer was in meters per second, and it was 2204.4.
So you're saying it's a number, not a, it's a decimal, not a percentage?
Yeah, I don't think it's a percentage, and
Okay.
I don't know. This is so confusing. Like, it makes sense in the homework when I get the answer right, but then when I do it on the homework or anything else, I'm like, if there's no answer, I'm just like, okay.
All right. I think we got that one. We just have to do this last one and do it for the 80th percentile this time.
So 0.68. That's how we're gonna.
687. If we're doing 3 decimal places, it's 0.687.
Oh. It doesn't say though. It doesn't say do it 3 decimal places.
I know it doesn't, but that's what the rest of the assignment was doing. I don't know. But unless we're supposed to put the entire number in there, do we do all of it? No rounding? I got, where did it go? 6.68695.
Should we just put that?
Well, if we base it off of the homework had 2,204 and like 3 decimal places, didn't it? Not the homework. The
prep?
Oh, it has 3 decimal places. I don't know.
I don't either. I'm just gonna leave it as, like you said, 0.687.
Okay, so then for the last one, it's the same thing, only do it with the 80th percentile. Which makes the z-score 0.842.
Yes.
Okay, I got 0.71894.
So do we round that and put 0.719?
If we're going to answer it like the last one, yes.
Okay. Well, then it looks like we have all of them.
So you said 0.781?
0.719 would be the rounded answer. Is that what you got?
Mm-hmm.
All right, are we ready to submit? You want me to go first since I switched my answers?
Wait.
That's kind of cheap, but like if we change our answers, like that doesn't seem quite
I'm
right.
leaving it.
You what?
I'm leaving the answers the way it was.
Okay, we're going to go. Ready? Submit.
Oh my gosh, we got an
What?
A.
Oh my gosh, we did. What did we get wrong? A minus.
We didn't get those wrong.
What
We
you
got
said?
16 and 17 wrong.
Huh? You got a what, you said?
16 and 17 we got wrong.
I got a 90. What did you get, Jennifer?
Wait, then 1 second. 1 second. Let me make sure I'm submitting it. I don't know. Probably not a good score. I was distracted by my daughter over here. It's loading and trying to figure out the percentage.
How can we get the 30?
80,
You got what?
80%.
Did you get 13 and 14 wrong?
I got, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then 13, 14, 17, and 16 wrong. But didn't we put the same answer for 14 and 13? Oh yeah, I put them backwards.
You
Never
put
mind.
them
I
different.
remember.
Okay, so 16, is this supposed to be the solution underneath it? 0.76 minus 0.196. Oh, we subtracted the wrong number. That's why we got it wrong. We should have subtracted the portion from 13 instead of the one from 14. Did you get 16 right, Jennifer?
6, no.
Hmm.
Because that was when my daughter was over here screaming and crying. And I had to go see the door. It was a mail. They wanted me to sign something.
Okay, I think that's why the top, but why did we get this one right?
Yeah, I don't know why we didn't get 17 right.
I don't either. Because it was
Because
done
it's the same thing as
way.
18.
18. Let's see. Did we round wrong? No. All right. Okay, well, I have a question. If we can move on, I have a question about the homework.
So for which one? Lesson 4 or 5?
Lesson 5, number 9. How do we do number 9?
Emma, stop. No, this is my computer.
It says using the 68, 95, 99.7 rule, approximately what percentage of the students will complete the exam in less than 1 hour? There was one on the homework quiz, too. I couldn't do that one and got it wrong also when I did the homework and the homework quiz. Any thoughts? I know what the answer is because I took it from the answer key, but I don't know how they got it.
Number what again? 9?
9.
I haven't done the homework, so
I'm not there yet.
I'm gonna I'm gonna take it offline or make it not live.
Okay.
Yeah.